Welcome to our discussion of logic statements and their negations. This is the first of 4 videos I'm doing on logic, which is a tricky subject for a lot of students. It's not that the subject material is difficult per se. It's just kind of new and it's a little clunky. The easiest thing to help you through these sections is to always try and do truth tables and label things with T's and F's and that kind of stuff really helps. Okay, let's start off with our objectives for this video, which is just one. We need to know how to take kind of these English statements and then put logic symbols on them to help us figure out whether or not something is true or false. So when we talk about mathematical logic, um, it can be difficult because we're dealing with the English language, and the English language is riddled with horrible stuff as far as not being logical. There are things that sound one way but mean something else, and there are opinions and sarcasm and riddles and all sorts of things that can make it very difficult, which is why we always try to take our statements and translate them into symbols, because then the symbols tend to get rid of a lot of that ambiguity. So just keep that in mind. That and another thing that really messes with students with these types of sections is we are evaluating these statements for being true or false based on their face value, not based on if they are actually factually true or factually false. Meaning you will come across statements in whatever class you're taking, and it will absolutely be false. In the real world, it's talking about something that's not true. But the way the statements are worded, they're true on the surface of their statements. And so just keep that in mind, that oftentimes when we're evaluating these statements, you have to kind of forget about what's happening in the real world, and you just have to look at the statements as just pure symbols that don't mean anything in the real world. They just mean something with the symbols that we're using. And I'll point out some examples when we get there. Okay, so a statement is a complete sentence that asserts a claim that is either true or false, but can't be both true and false at the same time. The following are some simple examples of mathematical statements. So A, the statement, the car is blue and the cat is black. And then statement B, the first even number is 2. You can see that both of those things are statements because they claim something, and they're either true or false, but they can't be both at the same time, right? Either the first even number is 2 or it's not, and in this case it is. And then either the car is blue and the cat is black, or it's not the case, right? And this is a compound statement. Those get tricky. So let's say you have a blue car and a brown cat. Is this statement still true? And the answer is no, because even though the car is blue, the cat was brown, and in order for the statement to be true, the whole thing has to be true, so they both have to be true, right? If the car is yellow and the cat is black, also not true. Obviously, if the car is yellow and the cat is brown, then it's totally not true, and the only time it's actually true is when the car is in fact blue and the cat is in fact black. That's another place where this really messes with kids' heads. Okay. A paradox is a sentence that contradicts itself and therefore does not have a single truth value. So a paradox cannot be a mathematical statement because it doesn't follow the rules, right? A statement has to be either true or false. It can't be both at the same time. A paradox contradicts itself, so therefore it's not true and it's not false, and it's kind of both at the same time. So it's almost the exact opposite of a statement. So let's determine if the following sentences are statements. It is raining outside. Does that make a claim? Yes, it does. Can that claim be true? Yes. Can that claim be false? Yes. Can it be both at the same time? Can it both be simultaneously raining outside and not raining outside? Not really, right? Let's not be pedantic about it. Well, what if it's raining and then it stops raining? Well, then at one moment it was true and at one moment it wasn't, right? So you got to look at just one snapshot in time. Okay, beaches are the most beautiful place to vacation. That's a claim. Can it be true and can it be false? Well, Isn't it kind of an opinion, right? Beaches are the most beautiful place. So this is where it gets a little murky. That sounds like an opinion. So can it still be a statement? Yeah, it can. Some people would argue that it can. Some people would argue that it can't. The truth of the matter is, if it's an opinion, it's not a statement because an opinion really can't be shown, right, or proven to be true or false. It's an opinion. Um, you know, Star Wars, the first one, was the best movie ever made. Well, that's someone's opinion. It can't be proven true or false. Now, if you turned around and said Star Wars was the highest grossing film of all times because you think that somehow says whether or not it was a good movie, well, that's no longer opinion because that's something that can be proven true or false by just looking at box office numbers. Okay, today is Monday. Statement or not a statement? Of course it is, and it can be true or false, but can't be both. Today is Monday and tomorrow is Friday. Ooh, now there's a tricky one, right? Think about that one for a second. Does it make a claim? Yes. Can it be true or false, but not both at the same time? Well, the only way it can be true is if both pieces are true. So in order for it to be true, today would have to be Monday and tomorrow would have to be Friday, which is impossible. So this is actually never true. This thing is always false because today could be Monday, but tomorrow would never be Friday. And then when we're at Thursday, it's no longer Monday, but tomorrow is Friday. So we can make the first part true, we can make the second part true. We can't make them both true. We can easily make them both false, right? We could, if we're sitting at Tuesday or Wednesday and a bunch of different things, then both parts are false. But this is still a statement because even though it's always false, right? A statement doesn't have to be true at some point. It just can't be both true and false at the same time. What about the last one? I lie all the time. Does that make a claim? Absolutely. Is it something that we can, show to be true or false? Absolutely. So it feels like a statement, right? Is it something that is either true or false but can't be both? Well, let's say the statement is true. If the statement is true that I lie all the time, then that means I am always telling the truth. And right now, I'm telling the truth that I lie all the time. But if I'm telling the truth right now, then I don't lie all the time. And therefore, it just makes my head hurt, right? It doesn't work. So that's one of those fun little verbiage things where it's both true and false, right? It's a paradox. It's a contradiction. It can't work. E is a paradox and is not a statement since it contradicts itself and therefore has no truth value. When in doubt, don't choose paradox because those are pretty hard to come up with. You really have to massage words to get a paradox. Doesn't mean they don't exist, but it just means that if you were taking a test and you had to guess, it's most likely not a paradox. All right, let's try this skill check. Were you able to write down two statements of your own that one is always true and one is always false? There are too many examples for me to go through, so hopefully you get the idea. All right, let's talk about what a negation is. The negation of a statement is not the same thing as a negative of a number, right? The negation of a statement is the logical opposite of that statement, or it's kind of, you can think of it as its denial. Negations always have the opposite truth value of the original statement. And when we're dealing with simple one piece statements, 2 is the first even number. Today is Monday. Anything that isn't a compound statement, right? So any of those ones that don't have ands and ors and things like that, it's just one little statement. Those are really easy to make negations because all you have to do is change it. 5 is a prime number becomes 5 is not a prime number. 2 is the first even number becomes 2 is not the first even number. It's really easy just to slap a not onto most of these. Today is Monday, today is not Monday. You see, it really is that simple. Because whatever the value of the first statement is, when you throw that not into it, the other statement is always going to be the opposite. So whenever the first statement is true, the second statement becomes false, and vice versa. Whenever the first statement is false, the second statement becomes true. Now, sometimes when there are quantifiers in your statements, it gets a little trickier. So like I said before, if it's a simple just this is that kind of question, it's really easy to make it a negation by just throwing a not in it. But when you throw quantifiers in there, or when you start making them compound statements with ands and ors, and then if-thens and all those types of things, which we'll see later, that's when it gets a lot trickier. So let's start with the next level of difficulty, quantifiers. Quantifiers are words that, as they sound, quantity, they give you an idea of how much of something you have. All, some, none, no, those are all quantifiers, right? All is all of it, right? None and no is none of it. Some is some portion of it, something between all and nothing. And to negate those quantifiers, it can feel a little tricky. So we have this table to help you figure out the pattern, right? You don't want to just memorize this table. You want to figure out the pattern. When you have the quantifier all are, then you're saying the entire group of things has a certain quantity, has a certain quality. So this entire group is something. To negate that, all you have to do is say that that's no longer the case. And if all of them have a certain characteristic, then to make that no longer the case, you just need at least one of them to no longer have that quantity, right? So when it starts off with all are blank, the negation can either be not all are blank, some are not, or at least one is not. You see how all three of those are the same thing. Instead of the entire group of things, let's say all of my siblings have brown hair. Okay, so now there's a bunch of people that I'm related to and they all have brown hair. And if all of my siblings have brown hair, that's true. If I wanted to make that statement false, which is kind of the same way as negating it, you just want to think about it as kind of turning it into a false statement, then all I have to do is dye at least one of my siblings' hair blonde, right? I don't have to go and dye them all blonde, but if I did, that would still make it false. I just have to take one of them and make their hair not brown, right? It doesn't have to necessarily be blonde, but you get the idea. So those three negations all make that situation no longer true. Not all of them are blonde, so one of them isn't. Or some of them are not blonde, or at least one of them is not blonde. I keep saying blonde. I know the original was brown, sorry, but you get the idea. Okay, now when your original statement is some of them are this thing, right? So some of my siblings have blue eyes. Some of them. To make that false, I need to make none of them have blue eyes. Do you see how that works? Because if just one of them has blue eyes, then that statement is still true, that some of them have blue eyes. So the only way to make that statement false is to make sure that none of them have blue eyes. So some goes to none. Some of them are not older than me, right? Some of my siblings are not older than me, which is a really stupid way of saying some of them are younger, but we have to deal with this case because sometimes statements are worded this way. So some are not a certain thing. Well, to negate that, right? So some of them are not older than me, which means some of them must be younger, right? So some of them are not older. If I make all of them older, then that's no longer the case, right? So if I have one sibling that's not older than me, then my original statement of some are not older than me is true. If I now make that one sibling older than me, then now the statement is no longer true. So some are not becomes all are. And then the last, none of them are blank means at least one is or some are. It's the same thing as the first case, right? The first case, you see how all and none are extremes? It's either all or none. And when you switch them, they go to the in-betweens, some and at least one. And then none goes to at least one and some. The only difference is we don't show none going to not all, right? We had all going to not all, which is kind of the same thing as none. And then we have all can also go to some and at least one. None can go to at least one, some, and it can also go to all. They should have put this one in here because if none of them are, then all of them are not, right? You see how that works? So just keep that in mind. And then the sums, right? Some are and some are not, both go to none are or all are. You always go from an extreme to a wishy-washy or from a wishy-washy to an extreme when you're trying to negate these things. That's the key. All right, let's try a few. Let's negate the following statements. Melanie is wearing a raincoat. Well, isn't that really easy to say Melanie is not wearing a raincoat? The door is not closed becomes the door is closed. Now here's where it gets tricky. None of the tourists brought raincoats. So how do we negate a none, right? A none is an extreme one, right? It's all the things, right? None of them and all of them. It's both the same thing. So none of the tourists brought raincoats. Can't we just change that to some of the tourists did bring raincoats, right? Some of them brought it, or at least one of them brought it, that kind of thing. I run less than Kara. Well, how do we negate that? I do not run less than Kara. So Melanie is not, the door is not, some of the tourists brought, and then D, the tricky one, I do not run less than Kara. Notice that we could also write I run the same as or more than Kara, because both are the same thing. So whenever we have less thans and more thans, remember that to negate that, you just need to find the other. And the difference of less than is greater than or equal to, and the same thing for the difference of greater than is less than or equal to. But you don't have to always change it that way, right? You don't have to go to a less than to a greater than or equal to. You could just say not less than. It just depends on if you want to kind of sound grammatically correct or not, because not less than is a kind of a clunky way of saying greater than or equal to. All right, try this one. Negate the following statement. Some of the students completed their assignments. Pause it and give it a try. And of course, some goes to either none or all, just depends on how you want to word it. So some of the students completed their assignments. The negation of that is none of them completed their assignments, or all of them did not complete their assignments. See how both of those kind of say the same thing? All right. A compound statement is composed of two or more statements that are joined together using the connective words either and, or implies. Now, in mathematical symbols, we use what most people call a caret. That is for and then the little V looking thing, that's or. Okay, so and or. Now, see if you can write these things in symbols. Now you want to just let one thing be P and one thing being Q. So snow is falling. Is that a single statement or a compound statement? Well, that's just a single. It's just one thing. Snow is falling. And we could call that P. And then the sun is shining, also a single statement. Call that Q. That's my way of writing a Q. Sorry, I know it looks like a 9 with a line underneath it, but that's my Q. And then snow is falling and the sun is shining. So here's snow is falling, here is sun is shining, and then and is this symbol. Okay, it's that simple. They use A and B. I like P's and Q's. Now, or can be thought of as the exclusive or the inclusive or. The exclusive or means you can have the first thing or the second thing, but you can't have both. And the inclusive or means you can have both. So a real obvious example of the exclusive or would be you are either younger than me or older than me. You can't be both. Right? You can't be both younger and older. Some of you might go, yeah, but what if we're the same age? Well, then you're neither, right? You're not younger, you're not older, you're not both. The inclusive or would be you could have brown hair or blonde hair, or you could have both, right? You could have streaks and things like that. So the inclusive or means if you have both, it still satisfies the question. The exclusive or means you have to be one or the other and you can't be both. When we're dealing with logic, we always use the inclusive or. And what that means is if you're evaluating a logic statement to determine if it's true or false, if it has the first characteristic or it has the second characteristic or it has both, then that is considered the whole thing is true, right? So we're always using the inclusive or when we're doing mathematical logic. So here's another example. Let P be the statement, he will go to the movies tonight. Let Q be the statement, he will stay home to give the dog a bath tonight. Let R be the statement, he will go to the movies tonight, or he will stay home to give the dog a bath tonight. How would we write these following things symbolically? Well, R is he will go to the movies tonight, or he will stay home. So isn't that P or Q? Okay, two statements can be joined together using the sentence structure if A then B. We call this combination an implication. It just basically means if A happens, then B happens, or simply put, A implies B. And the mathematical symbol for that is the little arrow. When you get into more complex ones where you have if and only if, right? A implies B and B implies A. So if A happens, then B happens, and if B happens, then A happens. And all that happens is this arrow has two heads on it. It faces in both directions. Now, let's use the following statements, S and T, to symbolically write the given compound statement Q. So S is the statement, the water temperature on Saturday is below 76.2. T is you are allowed to wear a wetsuit in the triathlon. Q says if the water temperature on Saturday is below 76.2, then you are allowed to wear a wetsuit in the triathlon. Can you see that they're basically saying if S happens, then T can happen. So S implies T. You should have S with a little arrow to T. It's that simple. Determining whether or not these things are true and false, that's where it gets a little trickier, and we'll do those in other videos. All right, so here's the symbols we talked about. The little caret is and, the little V is or, the little tilde, that's actually called a tilde, a little squiggle, that's not, that's the negation, just so you know. And then, of course, the arrow is implies. Some books use an actual minus symbol for not. Some I've seen use this little symbol. I don't know what the heck it is, but it's just weird. Just know that depending on your book, you might see different symbols for not. The rest are pretty standard, although instead of straight lines, sometimes they'll use the curved versions. Kind of looks like a horseshoe and a U. And then I've never really seen any different symbol for implies other than maybe one line for the arrow instead of two. And then, of course, you're going to see the double arrow is and I didn't make a typo. That's not if. That's if and only if. That's the shorthand for if and only if. And we'll see those in later sections. Okay, one last skill tech if you want to try it before you go. See if you can write the following compound statements mathematically given the statements A, B, and C. I am hungry, I am tired, I am in college. So see if you can write down I am hungry and tired, I am hungry or I am in college, and I am tired and not in college. Pause it and give it a try. And here are your solutions. All right, hope this helps.